Imagine a world where machines think, learn, and even create like humans. It sounds like science fiction, but it has been happening for over 70 years. From defeating chess grandmasters to generating viral videos from text, artificial intelligence has reshaped our reality. In this video, we are compressing every major AI breakthrough into just 10 minutes. Stick around. You will not believe how far we have come, or what is next. Let us dive in. Artificial intelligence is not new. It is a story of genius minds, grand ambitions, and stunning comebacks. We will journey chronologically through the highlights that shaped everything, from your smartphone assistant to self-driving cars. This is the ultimate AI timeline, explained simply. Our story begins in 1950 with Alan Turing, a brilliant British mathematician. He proposed a revolutionary question: can machines think? His answer was the Turing Test. If a machine could fool a human into believing it was another person through conversation, it could be considered intelligent. This was not merely theory. It ignited the entire field of AI. In the summer of 1956, a workshop at Dartmouth College, organized by John McCarthy and others, officially coined the term artificial intelligence. They boldly predicted that machines would simulate human intelligence within a generation. While their timeline was optimistic, this event marked the birth of AI as a formal science, paving the way for all future research. In 1958, Frank Rosenblatt invented the perceptron, the first artificial neural network. This system could learn from data, mimicking the neurons in a brain to recognize simple patterns. It was a fundamental building block, the direct ancestor of the deep learning systems that power our world today. In 1965, Joseph Weizenbaum at MIT created Eliza, the world's first chatbot. Posing as a therapist, it would rephrase user statements into questions. Though simple, people formed emotional connections, believing it understood them. Eliza demonstrated the potential for human-computer conversation, a concept that evolved into modern virtual assistants. Enter Shaky the robot in 1969. Developed at Stanford, Shaky combined vision, navigation, and planning to move around rooms and manipulate objects. It was slow, but it was the first robot to reason about its actions, founding the principles for modern autonomous robots and self-driving vehicles. The true key to modern AI arrived around 1970. Backpropagation. This algorithm allowed neural networks to learn from their mistakes by propagating errors backward and adjusting its connections. Think of it as tuning a massive radio, dialing out the static until the signal is perfect. Then, progress stalled. The early promises exceeded the technological limits, leading to the AI winters of the 1970s and 80s. Funding dried up, and interest waned. It was a period of quiet reflection, but crucial lessons were learned. The seeds planted earlier simply awaited more power to grow. The comeback began in 1997. IBM's Deep Blue stunned the world by defeating chess champion Garry Kasparov. Using brute force calculation, it evaluated 200 million positions per second. This victory was a psychological turning point, proving that AI could outperform humans in complex logical games and restoring global faith in the field. In 2011, IBM Watson achieved another milestone, crushing human champions at the game show Jeopardy! This required understanding complex language, puns, and context. Watson demonstrated that AI could navigate human knowledge, moving from games into real-world applications like healthcare and research. The true explosion began in 2012 with AlexNet. Geoffrey Hinton's team used deep convolutional neural networks and powerful GPUs to win the ImageNet competition, drastically slashing error rates in image recognition. This victory ignited the deep learning revolution, enabling everything from photo tagging to medical image analysis. In 2014, Ian Goodfellow invented generative adversarial networks, or GANs. This framework pits two neural networks against each other. One generates fakes, the other tries to detect them. Through this competition, AI learned to create incredibly realistic images, art, and media, unleashing a new wave of creative and controversial tools. In 2016, DeepMind's AlphaGo achieved what was thought to be impossible for a decade. It defeated world champion Lee Sedol at the game of Go. Go is immensely more complex than chess, requiring intuitive, human-like strategy. AlphaGo proved that AI could master nuance and uncertainty, a skill with profound implications for science and business. Then, in 2017, a Google paper titled "Attention is All You Need" introduced the transformer architecture. This breakthrough allowed AI to process entire sequences of data at once, understanding the context and relationship between words with unparalleled efficiency. It is the fundamental technology behind every major large language model today. OpenAI's GPT-3, launched in 2020, scaled this transformer architecture to an unprecedented degree with 175 billion parameters. It could generate human-like text, write code, and compose essays from a simple prompt. It demonstrated the remarkable creative potential of AI, while also highlighting significant challenges like bias and resource consumption. In November 2022, AI truly went mainstream with the launch of ChatGPT. Based on a refined version of GPT-3, it provided a conversational and accessible interface that captivated the world. Reaching 100 million users at a record pace, it democratized AI, putting powerful generative capabilities into the hands of everyone. The evolution continued with GPT-4 and its successors. These are multimodal systems, capable of understanding and generating information across text, images, and even video. AI began to process the world through multiple senses simultaneously. Today, we are entering the era of agentic AI. These are autonomous systems that can plan and execute complex tasks over time, from managing projects to coding software. Coupled with advanced robotics, this is creating machines that can not only think, but also act in the physical world. The most profound impact may be in science. AI systems like AlphaFold are solving grand challenges like protein folding, accelerating drug discovery at a pace never before possible. We are witnessing the emergence of AI as a fundamental tool for scientific breakthrough with the potential to save countless lives. So, in just over 70 years, we have journeyed from a theoretical question to machines that can see, write, create, and discover. We have moved from teaching computers rules to building systems that learn on their own. This was not a straight line. It was a story of bold vision, painful winters, and explosive revolutions. The trajectory is clear. AI is becoming an increasingly capable and integrated partner in our world. The question for the next chapter is no longer, can machines think? But how will we collaborate with them to build a better future? If you enjoyed this journey through the history of AI, please support us by liking this video and subscribing to Blitz Explains for more content. Thank you for watching.